Hey everyone, I welcome you all to the 13th video of Module 5, and now it's time to go ahead and train our linear regressor model. That is, we are going to understand the complete training process in this video, then build one function for the overall training, and then train the model on the dummy dataset that we have already created in the one of our previous videos. So let's get started with this particular video. And now the time has come where we go ahead and combine all of these functions that we have created, one for the forward propagation and the one for the backward propagation, and then update the values of W and B. Based on this updated values of W and B, you are going to again get the cost function, and once the cost is calculated and if the last two cost values are converging about some decimal places, I'll say my training is completed. And all of these fancy things we are going to add over here. Now one thing I notice is I'll just get rid of this particular line of comment and just get the first 5 inputs from this description and simply paste it over here. And what is it going to return? It's going to return a lot of things. Okay, it's going to return a lot of things. The first thing it's going to return over here for us is the complete weights list, complete bias list, and also complete cost list. So what do I mean by all of this, right? So what I'm going to do in this training process is to track down all the weights I'm getting after every iterations, and then I'm going to create a list of all these weights and simply pass it out. So I'll just call it as weights. This is list of all the updated weight values in iterations, or you can also call it as epochs over here, because this whole process of forward propagation, backward propagation on your whole data is actually called one epoch. So you can call it as iterations or epochs, it's fine. Along with this, I'm also going to return a list of all the updated bias values in the iterations. Lastly, also do the same thing for cost, and because I'm writing the same thing, I'll copy this, paste it over here, list of all the updated, or I should say list of all the cost values based on W and B values in the iterations, right? And along with that, I am also going to return one more thing, which is not really going to make any sense as of now, but I'll just call it as I, which is going to be keeping the track of the counter. It's going to be the iteration count at the end of training. Okay, you will understand this particular part once the training loop is completed. And yes, so let's go ahead and start coding this particular function. So what all things I need? The first thing I need to set up over here for myself is the empty lists for weights, biases, and costs, where I'll be keep on appending the values over here after every one training loop is completed. So I can write a comment over here like list to store values for each epoch or iterations that will be used later for, let's say, for example, visualization. So list to store the values after each epochs to visualize later after the training is completed. So, or else I'll just give a better comment over here. Lists of updated weights and biases, and also the cost with respect to this weights and biases. I guess this is a better comment. And I'm going to initialize weights is equal to empty list, then biases also is equals to this empty list, and then costs is again empty list. But now because we are already passing in this W and B as the first value, I'll say that the first value of weights is W and the first value of biases list is B. Now based on this W and based on this B, we are going to have a cost value over here. So how are we going to calculate the cost value? Now for this, you need to understand how the training loop is going to work. So for this, let me just have this kind of multi-line comments. Now what all things I'll be requiring? I'll be requiring first of all how the cost is going to be calculated. And if you remember that over here, within the cost itself, we had called that prediction equation. And therefore, the first step is getting solved automatically. I don't need to get my prediction. I am automatically getting it over here. Let's say if you want to keep this step outside, then you can also pass in over here the y prediction along with the y, and that's going to solve that particular problem. But I'm fine with this. I can simply go ahead and first of all get my cost values. So the first comment I'm writing over here is get the cost values. Get the cost value based on the current W and B, which are already stored inside this list. We are going to take these values of W and B and calculate the cost out of it. After this, what is the next step? Once I have the cost, and I'm going to add that cost value to this empty list. Add this cost value to that empty list of costs. And after this, I'm going to check if this cost that I'm having inside this list, okay, if there are at least two values in this list, and if these values are converging. How do I check the converging? I simply take the difference between both the cost values and check that correct to some decimal places. If these decimal places are same, then it means that the cost has converged. So the third step over here would be to break the training loop. Break the training loop if the costs value are converging. How are you going to check this? I'll be explaining that while coding process is started for this. And if the loop is not stopped, update the values of W and B. By how? By calling this update parameters function, right? After this, the next step would be, once I got the output of W and B, I'll be adding these values to the respective list. I'll not always say that empty list over here. I'll just say that to add this cost value to that list. Add this cost value to the list of costs. Okay, adding these values to the respective list of weights and biases. Okay, after adding this, there is one last process I need to do, is to show my training. Let's say, for example, I am choosing after every 100 iterations, I want to show my user some kind of training if verbose is equal to true. So after this whole process is done, I got my cost value, I appended that values into this empty list, and after that I'll break the training loop if this cost values are converging. If it's not converging, I'll update the values of W and B, and I'll add those values to this particular list. And after that, once this process is done, I can simply print my training progress. Print the training progress after every 100 iterations. You can change these values to 500 if you like, maybe 200, whatever is suitable to you. And yes, this is something that I'm going to do. And now, because I also want to check how many iterations are happening until this kind of loop is not broken, for that I'll also need to initialize the counter. So that's my first step. So let me just call it as the 0th step, that initialize the counter. Okay, and the 7th step over here is, after every loop is completed, I want to update the counter value. And yes, after all of this thing is done, I'll be getting the return of this particular training function to be weights, biases, along with that what all things I have, costs, and the I value. The final I will be the last value that got updated into this training loop. So this is the whole process that I'm going to follow. This is the training loop. Okay, but the counter will be initialized outside of the training loop, and then the values will be updated, because if I'm upgrading the value of counter by 1, update the counter value by 1. And then if the loop starts again, if I again initialize the counter, it's going to set back to that previous value. And therefore the initialization of the counter will happen first, and then the training loop is going to start. So this is the whole process. All right, so I'll just leave this part out and write a comment over here that is to basically initialize the counter, right? Let me call it as I is equal to 0 in the first place. And now I want my loop to run forever. I want my training loop to run forever, and for that I can say that while true. So until someone asks to stop this loop is always going to run it. Now what is the first thing I want to do? I want to get the cost function, and for that I'll say that over here I want this cost function over here. Why am I not able to type something? Just let me, oh yeah, okay, never mind. So the first thing I want to do is I want to get my cost function, and all of the cost function inputs I'm going to copy paste over here. These are the inputs I'm going to give to my cost functions. This is my complete X train and Y train data that I'm passing along with the current values of W and B, right? Along with the current values of the W and B. And if I notice one problem over here, this X and Y are the full data that we are passing in the training part, and therefore I'll have to convert this to X and Y, or else it will raise a problem. This X and Y in itself is that either training or the testing data, right? So I guess this should be fine. And what is the output that this cost function is going to give us? It's going to give me only one value, that is the cost. So maybe I can call this that, like, the output that I'm getting from here can be called as cost. And now the next step would be to append this value of the cost in that cost list. So cost dot append. What is the thing I want to append? I want to append the cost value. So the first step is done. The first step is done. Get the cost value based on the current W and B. Now comes the second part. That is, add this cost value to the list. I'll just have that 1 and 2 together, and it's better not to write that same kind of comments over here. Rather have a better comments instead, right? I'll say that calculate the costs and append it to the respective list. So yeah, this is done. After this, the next step would be to break the loop if the values in the cost list have converged. What is spelling of converged? I don't know, but yeah, I hope this is correct. Break the loop if the values in the cost list have converged. Okay. How can I check it? I'll simply say that if the value of I is greater than equal to 1, which is simply indicating that if my counter value is having at least 2 iterations. So 0 is the first iteration, 1 is the second iteration. So until this condition is met, I am going to assume that I'll always have at least 2 values into this list. For this, when the value of I is 0, there is one value that I have appended over here, as you can see. The second value will be appended over here. When the updation of the I is equal to 1 will happen over here in this loop. So once that I is equal to 1 or greater than I equal to 1 happens, I know that this cost will always have at least 2 different values. And if there are 2 values over here, it's my duty to check if the cost has converged or not. And I'm going to track it correct to 13 decimal places. So what it essentially means over here is that you are having this kind of a cost list. That's it's having some kind of values 1, 2, 3, for example. All right. Now, what I want to check is every time in this loop, I'm going to get access to the last 2 values from the costs. Let's say that I'm going to just call it as cost dummy because I'm trying to check something on that. Now I want to find out from the cost dummy what is the last value. I can get it with respect to this -1. And just like that, if I want to get the second last value, I need to get it with respect to -2. And now what I want to do is I always want to grab this last and the second last value and check the difference between them. So what I'll do is, 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 dummy. -1. I'll do the difference part and get the output. And this output could be positive, could be negative if the cost value are not always decreasing or maybe not always increasing or whatever it is. I don't want to take any kind of risk, so I'll always take an absolute value on top of that, which is nothing but a modulus if you want to think about it. So even if I reverse this order, if I do -2 -1 over here, it's going to still give me a +1. If I remove this ABS, that is the absolute function, it's going to give me -1. So to avoid this kind of problem, I'll make sure to have that absolute value on top of that. So now if this difference is going to be less than that tolerance value that we had defined over here, 10 to the power of -13, only then I'll say that the convergence has occurred. So I am getting basically 13 decimal places accuracy over here, right? So I'll just get rid of this and code the same part over here. So if I is greater than 1 and at that same time the difference in the cost value, the absolute values different, cos of let's say -1 minus cos of -2. If this difference is falling below the tolerance value, then I have to break the training loop. If the training loop is not broken, then what? I am going to update the values of W and P. And how can we update the values of W and P? By simply calling this functionality on top of the if statement over here, right? So I'll say that update the values of W and B. And I'll say that I'm going to return two things over here. One is W, another is B. This will be equal to that. Now you will be wondering that I've given this input of W and B and I'm again returning the same type of variables W and B. Why have I done this? So the simple reason behind this is that every time this W and B will be updated, it's now going to act like a new value over here. So after this loop is completed, this W and B will not be 0, 0. It will be the new value that I am giving to this W and B, and the same process will keep on happening without any kind of problem. All right. So this is something that I have coded to update these parameters. Now I can simply go ahead and append this W and B values to its respective lists. I'll say that weights.append W and biases.append of that B. So that's about adding weights and biases with to its respective list. Now after that, we are going to print the training progress after every iterations. So now I'll again require an if statement over here, and I'll simply say that if, first of all, I need to check if the verbose is equal to true, because remember, if user wants to see the training progress, only then it will be shown. So if verbose is true, and then if the value of I is a multiple of 100, in that case you are going to show me the output. So I'm going to say that if verbose is true, so if verbose automatically means if verbose is true, and at the same time the value of I plus 1, because remember I is going to start from 0. So if the value of I is 0, it means it's already one iteration completed. And if the value of I will be 1, it means 2 iterations are completed. So like this I plus 1, if this is a, like what I'm doing over here is called as the modulo operator, which is used to check if something is divisible by 100 or not. So if I give you a quick idea of how it's going to work, if I say 100 percentage by 100, it's going to give you 0. Just like this, if I say 200 percentage 100, it's going to give you a remainder of 0. So if this value is divisible by 100, you will always get the output of 0. So yeah, that's what basically a modulo operator does. So what I'll do is I'll just go back to this original part and say that if verbose and this is equal to 0, and I'm just going to make sure that this is wrapped into this brackets, and I'll say that if this is something, then I want to print something out. What is the something that I want to print? I'll give this f string and say that I want after this many iterations, after I plus 1 iterations, my weight value is equal to this W, bias value is equal to B, and lastly the cost value is equal to cost. And this W is coming from this, B is coming over here, and this cost is coming from there. So I guess everything is good. And after this, I'll also write a comment over here. Print the training history after every 100 iterations. So if the value of I will be 99, it means it's 100 because we're starting from 0. And therefore, I'm having this extra 1 over here. Right? And once this is done, I'll also make sure to update the counter value by 1. And let's get it done over here. Update the iteration count. So I is equal to I plus 1. And that's it. After this, the loop will keep on repeating itself and it will always check the cost values. If these cost values are converged, that is, if the cost values of the last two values inside the costs list, if correct to 13 decimal place they are same, I am going to break my training loop, or else update my weight and bias value and print the output after every 100 iterations. So if everything has been coded over here smoothly, we should not get any type of errors. Let's go ahead and try to train our linear regression model by calling this train functionality. Now I just need to call this train functionality over here, and that's it. All of the other functions are getting called within this itself, so I don't need to worry about it. This is the main thing that I'll be running. So I'll just copy this whole inputs over here and paste it over here. And now instead of X, I'm passing my training data for X and also training data for Y. W and B are set to 0 currently, and learning rate is also set to 0.8, I mean 0.01, and then tolerance value I'm giving over here as 10 to the power of negative 13. I'll change this verbose value to true, and I guess everything else is fine. I'm satisfied with that. I'll just change this to iter count. Okay, what is the iteration count? Or I can also call it as epochs. How many epochs it took for that convergence to occur. And now if I run this code, guys, let's see what's going to happen. So yes, we are getting the outputs. It means everything is working fine. And the second thing I need to check is if the cost values are decreasing or not. After 100 iteration, it was 5.0 something. And now after all these iterations, after 3200 iterations, cost is 0.082 to something. And you can see that these values are started to converge, and this is the last 100 iterations before 3200. So the convergence process is still working because it's not converged correct to 13 decimal places. And clearly we can see that the value of weight has approached to the value of somewhere close to 2. And the bias also you can see it's somewhere around 9.5ish. So the training has worked successfully over here for us. So yes, that's it about this particular video over here. I hope that by now you are familiar with how to create your own training function if you have to. And yeah, that's about this particular video, guys.